Okay, let's talk about problem 2 now. It tells us to consider this function, g of x equals negative 3x squared minus 4x plus 5. It wants us to determine whether or not there is a maximum or a minimum point, because I know it's a parabola, right? And how we know that's the case, they want us to find that, and then they want us to describe what the domain and the range are of the function. So it's helpful if we kind of remember when we do this, first of all, what maximum and minimums look like, right? So you have two different cases of parabolas, right? And I'll see if I can draw these without them looking too stupid. So you have one kind of parabola, right, that, kind of comes down and then sort of goes back up like that, right? And it's a curve. And so your lowest point, right, and I don't know if you can see that, I'll make it red. This point right here, your lowest point happens to be your vertex, right? Your vertex is along your axis of symmetry, which would kind of be like through here, right? And it's the lowest point of the parabola. Okay, so what we would do is we would say that that is the minimum, because that means every other value for the parabola, which you can clearly see, is going to be higher than that. Okay, and that's when a is greater than 0 and it's opening up. And you figure that out from learning how to graph these and from seeing that, but what we're looking for is you're looking for that leading coefficient. That's what the a is, right, from our ax squared plus bx plus c. You look at that leading coefficient, and if it is positive, you know that your parabola is going to open up. Okay, and then if it opens up, that means that the vertex is going to be the minimum point. The y-coordinate of the vertex is going to be the minimum point, because your y-coordinate is what tells you, your height of things. All right, now let's say we've got something that looks more like that. Okay, let's kind of figure out our vertex would be like somewhere around here, right? Which means that my axis of symmetry would be approximately there. It doesn't really matter. It's just we're just trying to make a point here. And so that point right there, the vertex, right, is also going to be the highest point this graph has, right? So because it's the highest point, that would be called a maximum, right? Every other point is going to be lower than it. And so those are kind of the two general cases of how that looks. And like this one, a was greater than 0, it opened up. On this one, it's a is less than 0, and so it opens down, right? Which we can see from looking at it. Okay, so what we can do right away, looking at a specific function, is to look at your a coordinate, because your a coordinate is going to tell you if it opens up or down. And then I know it's going to look like one of these two, sort of, it more or less, it's going to look like that. It might be moved around a little bit, but the behavior of it's going to be the same. So let's take a look at this, right? So we've got my a coordinate is going to be the number in front of the x squared term, and so it's right there. And so my a is negative 3. Okay, and so in this case, is my a greater than 0 or is my a less than 0? And negative 3, right, is less than 0, right? Negative 3 is definitely less than 0. We know that, right? And so because of that, I know that this particular quadratic is going to open down. And because it is opening down, that means the vertex is going to be the highest point or the maximum. So I would say it is going to have a maximum. Explain how I know. Then I would say because a is less than 0, the graph opens down. Therefore, right, now use IE for therefore. Therefore, the vertex is the maximum. Right? So that's our maximum. So now when it says find the maximum or minimum value. Well, if I know the vertex is going to be the maximum, I find the vertex. So what we remember about that? Well, to find the vertex, first we have to find the axis of symmetry. So we got to use our x is equal to negative b over 2a over here. So we got negative 4 over 2 times negative 3. Okay, we got a lot of negatives happening with this thing. So we got a double negative going on right here. Apologize about the microphone there. So that's going to give me positive 4 over negative 6. Right? It's positive because you have two negatives. They make pos, and then negative times positive down here leaves me with a negative. And so my answer is going to be negative because a positive divided by a negative is negative. And then let's just simplify this. Divide them both by 2, and you get 2/3. And so that is my x-coordinate, is negative 2/3. Now, when I find my y-coordinate for this, right, I'm going to plug negative 2/3 into this equation. And so we're going to try to do this without driving ourselves completely crazy, right? Because there's a lot of, opportunity for some kind of confusing math on this, all right? So 4 times negative 2/3, and then plus 5, all right? So I am going to erase what we have over here, so we have a little more room to work. So remember, when you work with fractions and you're multiplying fractions, especially if you're multiplying them by whole numbers, you got to remember that a whole number is a number over 1. And when you multiply fractions, you just multiply your numerators together and your denominators together. And then there's also, you can, if you're familiar with it, you can use cancellation as well. So we are going to have negative 3 times, well, negative 2/3 squared is basically negative 2/3 times negative 2/3, right? So we have negative 3 times, well, negative times negative is positive 4, and then 3 times 3 is 9. So we have negative 3 times 4/9, right? And then we are going to, we have a negative times a negative here. So it's going to be a plus, and then 4 times 2 is 8/3. Right? Because it's 4 over 1, and 1 times 3 is just going to give me 3. And then plus 5. All right? So now let's simplify this a little bit more. So we get negative 12/9 plus 8/3 plus 5. Well, I can simplify 12/9 to thirds by dividing them both by 3. So I'm going to get negative 4/3 plus 8/3 plus 5. Well, when you add fractions together, you need a common denominator, right? So because these two are written as fractions and this one isn't, I am going to take 5 and I am going to rewrite it as a fraction. So we are going to make 5 into a fraction, you would multiply it by 3/3, a fraction with the same denominator. And 5 times 3 is 15, and you get 15/3. So that's what 5 is in thirds. So let's write that in there. Right, 15/3, and then because I have my denominator being the same, you just add your top numbers. So negative 4 and 8 is positive 4, and positive 4 and 15 is 19. So I have 19/3 for my y-coordinate of my vertex. Remember, your x-coordinate is what you got up here, right? And so my vertex is, and I'm going to do it in another color. My vertex is the point negative, or sorry, I wrote that wrong. No, I was right in there, right? It's negative 2/3, comma, 19/3. And so when it says find the maximum or minimum value, the maximum or minimum value is always your y-coordinate. So your maximum, right, or yeah, in this case it's your maximum value, is going to, you would say that, let me go back to black here, 19/3 is the maximum value, right? That's what we have. So the highest this thing gets is 6 1/3 units, right? And then everything else is going down. All right, so this is the answer to letter B, There's our maximum. All right, and now for domain and range, these go pretty quick, right? Domain is just what are your x values that you can put into this, and then the range is what y values do you get out of it. Remember, x is your input, y is your output. So you can put any x values into this equation because there's nothing where it could possibly divide by 0 or give you any kind of weird, strange, unexplained, bizarro things going on. So if that's the case and you can put anything in, you would say your domain is equal to, and then you would say all real numbers. All right, and I'll write it like that. You can write it however you want, and remember you can also use that like double R thing if you want, right? That's always fun. And then your range is what values are you going to get out? Well, I know from what I just did by finding the maximum value that it's never going to get higher than that. 19/3 is the highest this thing gets. So your range is going to be any y values that are equal to or less than this number, because that's a maximum. If it were a minimum, it would be all things that are equal to or greater than, right? So just kind of think about what it's going to look like, and if you think about what it's going to look like, it's a lot easier to visualize the domain and range. So this is kind of the process for these. It's kind of like the first half of graphing these, which I know a lot of us don't like, but it's, we use it enough so you get kind of familiar with it. So there's that, here's this one, here's that one, and there's that one. So hopefully this is helpful, and we'll go on to the next one in the next video.